Yesterday, we learned how to factor a trinomial. You don't have to flip back, but I'm just going to quickly go over one from yesterday. This is a trinomial because there's three terms. X squared is the first term, negative 11x is the second term, and 18 is the third term. This trinomial has a leading coefficient of 1. Okay, the leading coefficient is the very first coefficient as long as it's in standard form. So whenever you have a trinomial with a leading coefficient of 1, you can factor it by the bubble method. To get x squared, you have to have x times x. That way when you distribute, it'll produce an x squared. And then to get your numbers, you're looking for two numbers, and they have to multiply to 18, your constant value, and they have to add up to the number beside the x to the first, which is negative 11 for this one. The numbers that did that for us were negative 9 and negative 2. Because multiplied, they make a positive 18, but added, they make a negative 11. So the answer would have looked like this, x minus 9, x minus 2. Okay, so that's what we did yesterday. But remember, yesterday, every single problem we did had a leading coefficient of 1. Okay? Every single one. We'll look today. Number 1, what's the leading coefficient? 2. Pay attention. This is view stuff. So what we're going to do is we are going to see if that 2 is also a greatest common factor. Can you divide 2 out of 2, 6, and 108 evenly? Yes. So this 2 is known as a GCF, a greatest common factor, and we're going to factor it out, which means we're going to undistribute it. We're pulling it back out of the trinomial. Now, when you factor out something, you're dividing it out. What's 2n squared divided by 2? N squared. What's 6n divided by 2? Positive 3n. And what's negative 108 divided by 2? Negative 54. Well, now that we have factored that 2 out, now don't we have a trinomial with a leading coefficient of 1? So can't we just factor that like we did yesterday using the bubble method? N times n will make the n squared. And now to find the numbers, we do what we did yesterday. Look for two numbers, and they have to multiply to give you a negative 54 though, and add to give you a 3. So what numbers will do that? Okay, 6 and 9, but what kind of 6 and 9 will add to a 3? Negative 6 and positive 9, right? Okay, so your factors are n minus 6, n plus 9, and so that is the answer. The 2 is included in the answer. Copy that, and then I'll explain why the 2 has to be there. The 2 has to be written as part of your answer. Okay, please pay attention. If I just ignore the 2 and I don't write it as part of my answer, watch what would happen. N times n is n squared. N times 9 is 9n. Negative 6 times n is negative 6n, and negative 6 times 9 is negative 54. And then wouldn't that combine to a n squared plus 3n minus 54? Is that what we started with? No, but if I have the 2 there and I now distribute it by everything in that trinomial, won't that make 2n squared plus 6n minus 108, which is what I started with? That's how I know that this is the right answer, because when I distribute all that back out and multiply it all by 2 at the end, it takes me back to my question. Now, you don't have to do this work that I just did. That's just checking it to make sure you have the right answer. All right, number 3. Okay, this time for number 3, what is the leading coefficient this time? 2. Is 2 also a greatest common factor for this trinomial? Yes, because it can be divided out of all 3 of these terms evenly. We'll learn that on the next page. Okay, so what is 2k squared divided by 2? K squared. What is 22k divided by 2? Positive 11k. And what is positive 60 divided by 2? Positive 30. So now that that 2 is factored out, haven't we created ourselves a trinomial that can be factored the way we did it yesterday by the bubble method? Okay, so you have to have k times k to make the k squared. And then you're looking for two numbers. And those two numbers need to multiply to a 30 and add to a 11. And that would be 6 and 5. 6 times 5 is 30. 6 plus 5 is 11. So remember, it doesn't matter which one you put where. I'll just put k plus 6, k plus 5. But you could have put k plus 5, then k plus 6. As long as you have both of those factors and the 2, that is the right answer. This time in number 5, John Michael, what is the leading coefficient? 2. Is 2 also a GCF for this trinomial? Yes, because 2 can be divided out of all three of those terms evenly. Okay, 2p squared divided by 2 is p squared. 2p divided by 2 is p. However, I would go ahead and write in the 1 this time, even though you don't have to. That way, in a few minutes, when you go to look for numbers that add and multiply, you know you're adding to a 1. Because if there's not a visible number there, you might get confused. And then negative 4 divided by 2 is negative 2. So now that we have factored out the 2, we have created ourselves a trinomial like we learned how to do yesterday. We can factor by the bubble method. We need p times p to get the p squared. And we're looking for numbers that multiply to a and add to a 1. Multiply to negative 2, add to 1. Negative 1 and positive 2. Negative 1 plus 2 is positive 1. The negative has to be on the 1. So p minus 1, p plus 2. Guys, remember this also. Isn't the majority of y'all CDAs multiple choice? So even if you don't know how to factor, can't you just take each choice and distribute it out until you get the one that produces the question? Which honestly would take longer, but it's an option if you don't know how to factor. Okay, number 7. This time, what is the leading coefficient? 8. Is 8 also a GCF for this one? Yes, because you can divide 8 out of all three of them and get a whole number. 8b squared divided by 8 is? Right. Positive 32b divided by 8 is? B. And negative 96 divided by 8 is? Very good. Okay, so now we've created ourselves a trinomial that can be factored by the bubble method. And we're going to be doing v times v to get the v squared. And to get our numbers, they have to multiply to and add to 4. What numbers will do that? 6 and negative 2. Okay, and so v plus 6, v minus 2. No, not yet. Okay, now go to the top of the page. We're going to do the first even one together. You'll see why in a second. Everybody finished copying number 7? Okay, number 2. This time, what is the leading coefficient? Is it also a GCF? Yes, because you can divide every term up there by 5 and get a whole number. What is 5n squared divided by 5? What is positive 10n divided by 5? And what is 20 divided by 5? Positive 4. So now we have a trinomial that we can bubble method, but don't forget to keep bringing down that 5. It has to be part of the answer. So n times n, and then you're looking for numbers that do what? Okay, well 2 times 2 is 4, but it's 2 plus 2, 2. Right. There's no numbers to do that, so you cannot factor it. And if you were expected to do a problem like this, more than likely the answer choice would just say can't be factored, or you would just stop right there. Like on free response, you would just stop right there. Yes? Number 4, I'll let Peyton go first since she asked first. Peyton, what was the final answer?
So y'all should have 5b minus 4 times b minus 2.
Okay, so let's do the work to check and make sure she did it right. 5 is the leading coefficient. It's also a greatest common factor for this one because you can divide 5 out of all 3 of these terms evenly. 5b squared divided by 5 is 1v squared. Negative 30v divided by 5 is negative 6v, and 40 divided by 5 is positive 8. Then we now have a trinomial with a leading coefficient of 1 that we can bubble method. Please stop talking while I'm teaching. It's very rude. So now we're looking for two numbers that multiply to 8 and add to negative 6. Well, numbers that multiply to 8 and add to 6 are 2 and 4. But for them to multiply to a positive 8 and add to a negative 6, they both have to be negative. Okay, and see, that's the same thing Peyton got. She just wrote her factors in a different order, but that's fine. Okay, number 6. Okay, Kiera, what was your final answer? Okay. Let's go over it. Please stop talking while I'm teaching. It's very rude. 4 is the leading coefficient. It's also the GCF because it can be divided out of every term up here evenly. When I divide it out of all 3 of those, it leaves me v squared minus 1v minus 2. So then I go looking for numbers that will multiply to a negative 2. And those same 2 numbers must add to a negative 1. The only 2 numbers in the world that multiply to 2, because it's prime, are 2 and 1. So it has to be 2 and 1. But to get those to add to a negative 1, the 2 needs to be negative. So that's how she ended up with a v minus 2 and a v plus 1. Yep. Okay, number 8. Who would like to give me their answer for number 8? Okay, Mallory. V plus what? 9? 1? Okay. Okay, let's check it. Pay attention. 6 is the leading coefficient. It's also a GCF because it can be factored out of all 3 of these evenly, divided out. That leaves a v squared plus 11v plus 10. So you're looking for 2 numbers. They must multiply to 10, add to 11. Those numbers are 10 and 1. 10 times 1 is 10. 10 plus 1 is 11. Okay, next page. Okay, listen. I am aware that these are more difficult. So what I suggest is that you let me work number 1 without interruption and that you just watch. And then I will give you time to copy it after. Because if you're trying to copy, you're missing steps. Every time you look down to copy, you're missing something. So just watch and don't stop me. Just let me finish a whole problem, okay? All right, number 1. What is the leading coefficient? 6. However, it is not the GCF because even though you can divide 6 out of this evenly, you cannot divide it out of 25 or 14. So we have to learn a new method for these types that have a leading coefficient greater than 1, but that coefficient is not a GCF. You have to start by multiplying and adding, and you're still going to add to get that middle number, negative 25. But since we couldn't factor out the 6, you multiply the 6 by the 14, and so it makes it 84. Okay, let me say that again. Let me say it again. You're still adding to get the middle number, negative 25. But instead of just multiplying to get a 14, you're multiplying to get 14 times 6, which is 84. You can't just ignore the 6, it's there. So you multiply it by the 14, and that gives us a new number to multiply to get. So, if you're having trouble thinking of numbers that multiply to 84 and add to negative 25, use a calculator. Start with 84, and since it's an even number, divide it by 2. Are 2 and 42 going to make a 25? No. So divide it by the next even number. Are 4 and 21 going to make a 25? Yes. So there's your 2 numbers, 4 and 21. Now we just have to decide about signs. Okay, because 4 times 21 is 84. But is 4 plus 21 negative 25? Make both of them negative, and when you multiply, it'll still be a positive answer, but if you make both of them negative down here, added will make a negative 25. So now we have n minus 4, and we have n minus 21. However, you're not finished, because think about it. If I were to distribute that back out, is n times n going to produce 6n squared? Well, no. You divide both of your factors by 6. And just keep watching. Now, in the next step, you're going to reduce both of those. What will 4 over 6 reduce to? 2/3. And then n minus, what will 21 over 6 reduce to? Look, if you're having trouble reducing in your head, watch. If you go to alpha y equals n over d, then type in the fraction that you're trying to reduce, it will reduce it for you. 7 over 2. Okay, so now the final step is these denominators get kicked out to the front. So it becomes 3n minus 2, and then this one becomes 2n minus 7, and that is your final answer. Okay, go ahead and copy it. Okay, number 3, what is the leading coefficient? 6. Is 6 also a GCF? No, because it will not divide out of 19 or 7 evenly. So we have to use our new method where we multiply to get a number and add to get a number. Now you're still adding to get that middle number with the n, which is negative 19. But this time, instead of multiplying to get a negative 7, you're multiplying to get a negative 42 then, because negative 7 times 6. So what are some numbers that will do that? Well, 6 and 7 won't work because they won't make a 19, so think of other numbers. Use your calculator if you need to. 42 divided by 2. Won't that make a 19? 21 and 2. Okay, but to get to negative 19, what kind of signs do you need? The 21 needs to be the negative so that when you add them, it'll be a negative 19. Okay, so your factors are n minus 21, pay attention, and n plus 2. But the reason we can't stop there is because n times n is not 6n squared. So we have to divide both of these by 6 and then reduce. Okay, both of these are divisible by 7, so 21 over 7 is 3. Never mind. Both of them are divisible by 3, so 21 divided by 3 is 7. 6 divided by 3 is 2. But remember, like I said, if you're having trouble with reducing, your calculator will do it for you, alpha y equals n over d. What will 2 over 6 reduce to? 1/3. And then look, for your final answer, you just bring these denominators out in front. So it'll be 2n minus 7 and 3n plus 1. And then you don't have to, but remember, if you're not sure you did it right, what can you do? Distribute it out, and it should take you back to your question. Yes, Marty? Pay attention. Last one for today. What is the leading coefficient? Is 4 also a GCF? No. So we can't do it the way we were doing it earlier today. We have to go back to our method of immediately multiplying and adding to find two numbers. They have to multiply to a what this time? 24. Because 6 times the 4 up front is 24, and they have to add to a negative 11. What numbers do that? Very good. Negative 8, negative 3. So then your factors are n minus 8 and n minus 3. But why are we not finished? Why can that not be the answer? But why can it not be the answer? Correct. N times n is not 4n squared. So that's why you have to divide this one by 4 and this one by 4. And then you reduce. N minus, what is 8 over 4? 2. And look up at the board for a second. Think about it. Isn't it really 2 over 1? But is kicking a 1 out to the front going to make a difference here? No. So that's why you just write n minus 2. Will 3 over 4 reduce to a lower fraction? No, 3 over 4 is as low as it'll go, right? So now you're ready to immediately kick it out and get 4e minus 3, and you're done. That one was even easier because your fractions either reduced to a whole number or couldn't be reduced at all. Okay, we will continue working